Hello, this is video number 14 on my single variable calculus 2. In this video, we're going to go over trigonometric integrals. There are three types of trigonometric integrals that we're going to go over. First, we're going to go over integrals of products of sines and cosines of an angle x. Next, we're going to go over products of tangent and secant when the same angle x is used. And lastly, we're going to go over products of sine and cosine and sine and sine and cosine when you have different angles. So first we're going to start with products of sine and cosine. We want to evaluate these two integrals. So if you look at the first one, we are going to look for a u substitution that helps us evaluate this one. If we take u equals sine of x, we have the derivative of sine right here. So cosine of x dx would be derivative of sine. Now, sometimes you might have a plus minus sign. It doesn't really matter because derivative of cosine is negative sign. So that's the part that we have in there. But if we look at the rest of it, we get cosine of x and then sine cubed of x. We need to be able to write this down in terms of sine. Because if we can write this down in terms of sine, then we would be able to evaluate the integral. Well, we can't really do that. So instead of that, we're going to take u equals cosine of x. And then because the exponent of sine is odd, we can take out one of the signs, use that as du, and the rest of them turn it into u. So if we do that, we get du equals minus sine of x dx. So we can write down the integral of cosine squared of x sine cubed as sine squared times sine of x dx. Then we could use this part and replace it with negative du. So this is integral. Cosine squared is u squared. Sine squared is 1 minus cosine squared. And this one is minus du. Now this is an integral that we can easily evaluate because this is a polynomial. So we're going to distribute. We get negative u squared plus u to the fourth du. And this would be negative u cubed over 3 plus u to the fifth over 5 plus c. Once we substitute the values back, so u was cosine of x, we plug it back, we get minus cosine cubed of x over 3 plus cosine to the fifth of x over 5 plus c. And that would be our final answer. So let's look at the next one. If you look at the next one, if we separate the sine, we are left with one sine, so we can't write it down in terms of cosine. If we separate the cosine, we cannot write down the rest of them in terms of sine. So because both of these exponents are even, since both exponents are even, we can't use a u substitution for sine or for cosine. What we can do is we can use something called a half angle formula to reduce the exponents. What are the half angle formulas that we're going to be using here? So these are the two half angle formulas that you would have to remember. The first one is cosine squared of x is 1 plus cosine of 2x over 2. And the second one is sine squared of x is 1 minus cosine of 2x over 2. So if we look at the integral of sine squared of x times cosine squared of x dx, we can replace the first one by 1 minus cosine of 2x over 2, and the second one by 1 plus cosine of 2x over 2 dx. Let's now multiply that out. So this is a difference of squares. So we get 1 minus cosine squared of 2x dx. Now for simplicity, we're going to turn this into sine squared of 2x. Now again, we cannot do a u substitution for sine. So what we're going to do is we're going to use half angle formula again. So this would be 1/4 integral 1 minus cosine of twice 4x, twice 2x divided by 2. So it's the same formula, except that we're applying that for the angle 2x rather than angle x. So we're going to take out 1/2 from the inside. We get 1/8 integral of 1 minus cosine of 4x dx. And then we can apply either the u substitution, or we could say, well, integral of cosine of 4x is sine of 4x over 4. Because once you differentiate that, you get cosine of 4x times 4 over 4. So that's an easier way of evaluating the integral without having to do a u substitution. So integral of 1 is x, integral of cosine is sine, and then we'll have to divide by 4 and then plus c. So this would be x over 8 minus sine of 4x over 32 plus c. And that is our final answer. Okay, so next thing we're going to do is we're going to look at products of tangent and secant. So for product of tangent and secant, we need a couple of formulas to remember. First, derivative of tangent is secant squared. That's something we have discussed before. Derivative of secant is secant times tangent. Again, something we have discussed before. And then also integral of secant is natural log of secant plus tangent and then plus c. And you have absolute value for whatever is inside the natural log. Okay, so here is now how we approach this problem. So we're trying to find the integral of secant squared times tangent to the fourth. The idea is we want to use either u equals secant or u equals tangent. If we look at secant squared dx, this would be derivative of tangent of x. And the rest of it, which is tangent to the fourth, can be written in terms of tangent. It actually is in terms of tangent. So we can do a u substitution for tan of x. So u equals tan of x gives us du equals secant squared of x dx. Now we're going to plug in the values because this is a definite integral. So for x equals 0, we get u equals tan of 0, which is 0. For x equals pi over 4, we get u equals tan of pi over 4, which is 1. So this would be the integral from 0 to 1. Secant squared x dx is du, and then u to the power of 4 is what we have inside. So this is u to the power of 5th over 5 from 0 to 1. Plug in the values, we get 1/5 as the answer. Okay, let's look at the second part. The second part of this problem is the integral of secant tangent cube. So again, we want to use either a secant or tangent as the u substitution. We can break this up into secant x tan x dx, and then there's a leftover of tan squared x. This guy is derivative of secant of x. This guy, if you can write this down in terms of secant, then we are basically done. Well, we can do that because secant squared minus 1 is tangent squared. So that is another formula that you need to remember. That's one of the identities we have used before. So we're going to apply u equals secant of x. That gives us du is secant of x tan of x dx. So we're looking at integral of secant tan cubed. So this would be secant of x tan cubed x dx. This is equal to integral. Well, if you look at the inside, we have secant and we have 3 tangent. Well, 2 of the tangent squared x is equal to secant squared x minus 1. So that would be u squared minus 1, and the rest of it is du. So this is u cubed over 3 minus u plus c. And then we can plug in the values. We get secant cubed of x over 3 minus secant of x plus c. So that is the answer to this part of the question. Let's look at the third part of this question. This one is more complicated. So the integral of secant cubed of x dx. Well, what happens if we do u equals tan of x? If we do u equals tan of x, then we need du. Well, du is there. We have sine squared secant squared x dx. But the problem is if we break this up into secant times secant squared dx, this portion is d tangent of x. But this portion is not in terms of tangent. Secant of x cannot be written in terms of tangent. So this is not going to work. If we try u equals secant of x, well, we get du equals secant of x tan of x. We don't really have a tan x. So we can write down secant cubed as secant of x times secant squared of x and try to create a tangent there. But secant squared is tangent squared plus 1. So that's going to give us a trouble because we don't have really a factor of tangent. So here is the idea. We're going to use integration by parts after splitting secant cubed into secant times secant squared. So we're going to write it down as integral of secant times, I'm going to just write down secant cubed first. And we are going to break this up into secant and then secant squared. Now we are going to take u equals secant of x, dv equals secant squared x dx. So then we have du equals secant tangent dx, and v equals integral of secant squared, which is tangent. So this is going to be equal to uv, which is secant of x tan of x, minus integral of v du, which is tan of x, and then du, which is secant of x tan of x dx. So I'm using integration by parts in this equality. So this one is u, this one is v, so this is v, and this one is du. Okay, so let's see. Now we got to another thing that is also not really possible to evaluate. So let's simplify that. We get secant x tan squared of x. Well, we can't really evaluate that using the techniques that we have learned. If you do u equals tan of x, then you need its derivative, which is secant squared x, but the exponent of secant is odd, so that's not going to work. If you do u equals secant of x, derivative of that is secant tangent, but we only have two tangent. One of them is used for du. The other one must be written in terms of secant, but that's not possible. So what's the strategy to deal with this situation? Well, what we're going to do is we are going to replace tangent squared with secant squared minus 1. And if we do so, then let's see what we get. We get tan secant times tan minus, let's distribute, we get secant cubed of x dx. And then we get plus integral, because we have a minus sign here and we have a minus sign here. So we get plus and then integral of secant of x dx. Now let's see what happened. We have negative what we started with from the beginning. We started with integral of secant cubed and we ended up with negative integral of the same thing on the other side. If you recall, we had a very similar thing happen when we were doing integrals of e to the x sine of x and also e to the x cosine of x in the previous lecture. So the strategy was to move those two things to the same side, so we get twice the integral of secant cubed dx equals secant of x tan of x plus, and then we know this integral. So I'll write it down in the next step. So that tells us integral of secant cubed of x dx is equal to 1/2 secant of x tan of x So because we have a 2 in front, we'll have to do 1/2 plus integral of secant is natural log of absolute value of secant plus tangent. That's something we discussed, plus c. So that is the answer to this problem. So the last type of integral that we learned today is about integrals of products of sines and cosines, but the angle is different. So for that, we use 3 trigonometric identities. Now, if you don't remember these identities, you might remember these better. Sine of x plus y is equal to sine x cosine y plus sine y cosine of x. And if we do sine of x minus y, we get sine of x. So replace y by negative y. Cosine of negative y and cosine of y are the same because cosine is even. Sine of negative y is negative sine of y because sine is odd. Sine is an odd function. And this one is cosine of x. Now, if you add up these two, so these, if you just sum up the two, you get sine of x plus y plus sine of x minus y is equal to twice. These two cancel. We get twice sine of x cosine of y. So that gives us the first formula here. So if you look at this one, that's exactly sine x cosine y is 1/2 of sine of sum plus sine of the difference. Now remember that sine is odd, so sine of x minus y and sine of y minus x are actually negative of each other. We can do something similar for cosine. We know cosine of x plus y is equal to cosine x cosine y minus sine x sine y. And we also know cosine of x minus y. If we replace y by negative y, we get this similar identity here. Cosine is even, so we get cosine of negative y, which is the same as cosine of y. And this one becomes positive sine of x, sine of y. Now if we add these up, so we sum them up, we get cosine of x plus y plus cosine of x minus y. These two cancel, and what is left is twice cosine of x cosine of y. And this is the third identity that we got here. And then we can do the same thing by subtracting these. If you subtract them, so subtract, you end up with cosine of x minus y minus cosine of x plus y. So if you take the bottom, so this one, and subtract the top one from that, you would get twice sine of x sine of y. And this is the second identity that I wrote up there. Now, you don't have to know how to drive these formulas, but I thought maybe some of you might be interested in knowing where these come from. So this would be the place that you must have seen it before in pre-calculus. But you do need to remember these formulas. Okay, so we're going to apply them in these 3 instances. So the first one is integral of product of sine. So product of sine, integral from 0 to pi over 3. Product of sine is 1/2 of cosine. Well, it's cosine of difference. We could do 2x minus 3x. We get a minus x. And then minus cosine of sum, which is 5x dx. Now we can use the fact that cosine is in fact an even function, so we can put the 1/2 out, 0 to pi over 3. Cosine of negative x and cosine of x are actually the same thing. So negative cosine of 5x dx, this is 1/2. Integral of cosine is sine, so this is sine of x minus integral of cosine is again sine of 5x, but we're going to have to divide by 5. and this is from 0 to pi over 3. Let's plug in the values. We get 1/2 sine of pi over 3 minus sine of 5 pi over 3 divided by 5, and then minus 0. Sine of 0 is 0. Now let's see what we get. Well, sine of pi over 3 is root 3 over 2 minus 5 pi over 3 is in fact in the, if you look at the unit circle, 5 pi over 3 is pi plus 2 pi over 3. So it's like right here. So it's pi plus 2 pi over 3. So its sign is actually negative. So it's positive root 3 over 2. But then we have to divide that by 5, so I would get 10 at the bottom. So let's take the common denominator. We get 10 at the bottom here, and then we get 5 root 3 plus root 3. So that would be 6 root 3 over 20, which is 3 root 3 over 10. And that is the answer to this part of the problem. So we'll do 2 more examples and then we will summarize. I will tell you the general strategy for evaluating these 3 different types of integrals that we learned. The next one is the product of sine and cosine. That would give us sine. So we have the integral of sine of 2x cosine of 7x dx. So we're going to apply the product to sum formulas. This would be 1/2 sine of the sum, which is 9x, plus sine of the difference, which is negative 5x dx. Just be careful about the order of these two. It would have to be 2x minus 7x, not the other way around, because sine is an odd function. So those two things are actually negative of each other. So we're going to take the 1/2 out. And what is integral of sine? Integral of sine is negative cosine. But then I have to divide by 9. And then same thing here. So negative cosine, and then we have to divide by negative 5. Now, we also have like obviously a plus c because it's an indefinite integral. So we're going to distribute this. We get negative cosine of 9x divided by 18 as the first term. And then we have negative sign here, another negative sign here, so that's plus. Cosine of negative 5x and cosine of 5x are the same, divided by 10, and then plus c. So this is the answer to the question. Finally, the last part is very similar. We have to apply a different formula. That's really the only difference here. So we have product of cosines. So we'll have to take integral of 1/2 of cosine of the sum, which is, let's see what the angles were, 3x and 5x. So that would be 8x plus cosine of 2x, which is the difference of the two. And then we're going to take out 1/2, integrate cosine, we get sine, but because the angle is 8x, we have to divide by 8. And then that one would be sine of 2x divided by 2, and then plus c. So the answer to this is going to be sine of 8x divided by 16 plus sine of 2x divided by 4 plus c. So that's the answer to the problem. So now let's summarize and see what are the strategies that we can use in order to evaluate these types of integrals. As I said, there are 3 different types of integrals. The product of sine and cosine of the same angle. If the exponent of sine is odd, you split sine to the power of m into sine and then sine to the power of an even number. You write down everything else, all the other signs in terms of cosine, and then you use u substitution for cosine. And we do something similar if n is odd. So you take u equals sine if n is odd. One of the cosines is going to be used as du. The rest of them are going to be turned into sine. We write down cosine squared as 1 minus sine squared. If both of those two exponents are even, then we are going to use half angle formulas to reduce the exponent. When we are dealing with products of tangents and secant, if the exponent of tangent is odd, then we use secant as u, and we turn all of the tangents into secant by tangent squared equals secant squared minus 1. If the exponent of secant is even, then we will use secant squared as our derivative, as our du, and u equals tan of x. Everything can be written in terms of tan of x because secant squared is 1 plus tan squared x, and then we can evaluate that. If m is even and n is odd, you write down all the tangents in terms of secant, and then you use integration by parts as we did in the problem involving secant cubed. For integrals that are products of sine and cosine of different angles, we use product to sum formulas, which are sine x cosine y, 1/2 of sine of x plus y plus sine of x minus y. Sine times sine is 1/2 cosine of the difference minus cosine of the sum. Cosine times cosine is 1/2 the sum of cosine of difference and cosine of sum. And that brings you to the end of this video. I will see you in the next video.